Hello everyone, how are you doing today, dear students? In this particular video I'm going to talk about series and parallel circuits. So if you want to learn this, watch my video till end. So I'm guarantee you would be able to grab the concept of series and parallel circuits firmly. So let's get started. The circuit would be like this. This is the first component, resistor, and the second component would be joined with this like this. If you want to add more, so one end is connected with this resistor, and the second end is connected with another resistor, R1, R2, R3. All right, so we are attaching the battery with them, the source of EMF. All right, the source of EMF. This is the series circuit. Let me draw the parallel. R1, R2, R3. This is source of EMF, positive terminal, negative terminal, source of EMF providing voltage V. All right, so here the current will remain same throughout the circuit. All right, the current would remain same and voltage will divide. Some potential difference would be dropping across this resistor, and that dropped potential difference would be V1. Some potential difference across this resistor would be V2, and some potential difference would be dropped across this resistor, that would be V3. If you add V1 plus V2 plus V3, you are going to get the applied potential difference, the applied voltage. The applied voltage that the source, like the source of EMF is providing, this is the main voltage provided by the source of EMF, like battery, would be equal to the algebraic sum of the voltages across each component. All right, so this law is called Kirchhoff's voltage law. Kirchhoff's voltage law, KVL. All right, and here these resistors are connected in parallel combination. Voltage will remain same, but the current will divide. All right, the current provided by the source is I. The current going down is I1. Through this resistor would be I2. The current through this resistor would be I3. If you just add all of them, I1 plus I2 plus I3, so just see the difference. Here the voltage is dividing across each component, and sum of all the voltages dropped would be equal to the voltage supplied by the battery. And here the voltage supplied by the battery would be the same across each resistor. The voltage will remain same, but the current will divide. Voltage will remain same, the current will divide. And here the current will remain same and the voltage will divide. This voltage would be divided, right? So these two are in this sense are opposite. Like here the voltage remains same, the current is dividing. Here the current remains same, the voltage is dividing. And this rule is called KCL, Kirchhoff's current law. Kirchhoff was the scientist. He put forward these two laws, all right, for series and parallel combination of the circuits. All right, there are some compound circuits where we have a combination of series and parallel, but I'm not going to that. In the later videos, I will teach you that one also. But here in this particular video, we are going to talk about the difference between series and parallel. Here you can see all components are connected to the same wire or the same point. Like this point is connected at the one end. This same point is connected to another component. The same point is connected with another component. The same point is connected with another part of the circuit. So this point is common to all. That's why we are calling this point is node. So at this node, the total current entering the node is equal to the total current leaving the node. This is basically KCL, total current entering the node. This is the current that is entering the node, and these are the current which are leaving the node. This current is entering the node, and these three currents are leaving the node. Check out the arrow going away from this point, and this arrow is toward this point. So this is incoming current and these three currents are outgoing current. So total incoming current is always equal to the total outgoing current at any node. This is called KCL. And when we talk about the KVL, we must be having some closed path. This is the closed path, closed circuit. So we can apply KVL over here. The total potential difference provided by the battery or the source would be definitely divided into many potential differences across the components like V1, V2 and V3. If you just add all of them, you are gonna get the total provided by the battery. This is called the KVL rule, Kirchhoff's voltage law. The current is same in the series circuit. All right, so the current is same for R1, this current is same for R2, and this current is same for R3. So if you want to find out this V1, so V1 would be equal to, according to Ohm's law, V is equal to IR. So this would be equal to IR1. V1 is equal to IR1 because I is same for everyone. This is R1. V is equal to IR, the Ohm law. And here V2 is equal to IR2. And here V3 is equal to IR3. All right. So just do one thing. Let's apply this KVL. V1 is equal to IR1, V2 is equal to IR2, and V3 is equal to IR3. So this I is common, so let's take common, and then R1 plus R2 plus R3. All right, so this is the equivalent resistance, like R1 plus R2 plus R3 equivalent resistance you will get, but we are not going to write over here. We are writing like this: R1 plus R2 plus R3, and this I is basically going down over here on the other side. V over I is R1 plus R2 plus R3, and then this V over I is total R, that is R equivalent. So R1 plus R2 plus R3. So this is the equivalent resistance. Equivalent resistance means if you combine all resistance together, so you can replace these three resistors with one resistor only, and that one resistor would be of this value. All right, if you want to replace all of them with one, and its value would be R, and the R equivalent. All right, so now let's solve for this circuit. Here, as I told you, the voltage remains same. All right, so voltage remains same means if you want to calculate this I1, so this I1 would be I1 according to Ohm's law. I is equal to V over R, so voltage is same, so V over R1. I2 is equal to V over R2, and I3 is equal to V over R3. Why? Because the voltage remains same, so we are not writing V1, V2, V3, but resistors are different. That's why we are writing R1, R2 and R3. All right, so let's apply this equation. I is equal to I1 is equal to V over R1 plus V over R2 plus V over R3. All right, so here V is common, 1 over R1 plus 1 over R2 plus 1 over R3. So here is I. All right, then we are going to take this V on the other side. It would be written over here, 1 over R1 plus 1 over R2 plus 1 over R3. So I over V. V over I is R, and I over V is reciprocal of R. So it would be 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This would be R equivalent. In this combination, the reciprocals of each resistor are adding up, and we are getting the reciprocal of the equivalent resistor. This equation is valid for the parallel combination of the components, and here like I'm talking about resistors only, and here if the resistors are connected in series, will be approaching at this equation. R equivalent is equal to R1, R2 plus R3. You can simply add all of them and you will get R equivalent. For example, the value is 2 ohm, 2 ohm, 2 ohm. So total would be 6 ohm. For example, 10 ohm, 10 ohm and 20 ohm. The total would be 40 ohm. But here it's not easy. Like you have to apply this. All right. So for example, this one is you can say the 2 ohm, 2 ohm, and 2 ohm. So you will writing 1 over 2 plus 1 over 2 plus 1 over 2. And after solving this, you have to take the reciprocal again, because on the left side there is 1 over R equivalent. So you have to take the reciprocal at the end, and you are going to get the R equivalent. Do you know the home wiring is always parallel circuit? You know, it is not series, because if it is series, if one bulb or one tube light, or if one appliance, any appliance goes off or having trouble or is having fault, so definitely all others would be disconnected. This video would be helpful for you to understand and grab the concept of series and parallel circuits, but in the later videos I'm gonna show you different examples of series and parallel combination with the power calculation also. I'm gonna meet you in the next video. Till then, bye bye.